Today we are going to talk about special types of quadrilateral. So before getting into special type of quadrilateral, what is a quadrilateral? Any shape which has got four sides to it is called a quadrilateral. So it could be this shape, it could be anything with four sides. Okay? It could be anything with four sides. So there would be sorry, this is like a straight line. So this is called a quadrilateral. So anything with four sides is called a quadrilateral, right? A, B, C. Now, what all special things that can happen with this quadrilateral? The special thing that can happen with this quadrilateral is first, two sides of this quadrilateral could be parallel to each other. Let me choose black. So or rather blue. Two sides of this quadrilateral could be parallel to each other. So this side and this side, if they are parallel, right? Other two sides need not be parallel. So this and this side is parallel. These are not. So this is one type of quadrilateral that might, special type of quadrilateral that might come. Other way around could be these two sides are parallel, but this side and this side are not parallel. So the quadrilateral will look something like this, right? So this could be another type of quadrilateral. A, B, C, D, where this side and this side are parallel, these are not parallel. Similarly, A, B, C, D. This is called trapezium. This is called trapezium. So trapezium is a type of quadrilateral where two sides are parallel to each other. The remaining two sides are not parallel to each other. So that's trapezium. Now let's move to the next one. The second type could be where both the sides are parallel to each other. So this and this are parallel, this and this are parallel. A, B, C, D. So these sides are parallel. This is called parallelogram. Parallelogram. If the sides are parallel, this is called parallelogram. Now, from parallelogram, there might be multiple type of special quadrilateral might come out. So in all those quadrilaterals, the opposite side will be parallel to each other. But in addition to that, there would be some other special properties. For example, these two sides are parallel, right? So this side is parallel to this side. This side is parallel to this side. So this is a parallelogram. But in addition to two sides being parallel, the angle also is 90 degree. So this angle is 90 degree, this is 90 degree, this angle is 90 degree, and this is 90 degree. So if along with a parallelogram, if the angles are at 90 degree, this is called rectangle. So rectangle is a special type of quadrilateral, rather a special type of parallelogram where the angles are at 90 degree. Now what could be the second thing? Second thing could be the opposite sides are parallel, right? So this side are parallel. So I have A, B, C, D. This is parallel to this. This is parallel to this. So this is a parallelogram, but along with that, all the sides are equal. So this side is x centimeter, this is x centimeter, this is x centimeter, and this is x centimeter. Parallelogram with all four sides equal is called rhombus. So that is rhombus. So from parallelogram, we saw two things, rectangle and rhombus. There could be another one. What is that type? In that one, all four sides are equal. So it's a rhombus. It's a rhombus, which basically means opposite sides are parallel to each other. All four sides are equal. This is x centimeter, this is x centimeter, this is x centimeter, and this is x centimeter, right? But along with that, the another thing is this angle is 90 degree. So all four angles also is 90 degree. So a special type of rhombus where all angle are 90 degree is called square. So square could be represented in two ways. It is a special type of rhombus where all angles are 90 degree, or the another way is it is a special type of rectangle where all sides are equal. In rectangle, opposite sides are equal. Only if all sides are equal, it becomes a square. So we saw three different type of special quadrilateral which comes out of our parallelogram itself. So that's what we have seen. We'll revise it once more. Trapezium. What is trapezium? The opposite sides, only two sides are parallel to each other. These are not. This is trapezium. What is parallelogram? All opposite sides are parallel to each other. So this is parallel to this is parallel to this. It became parallelogram. What is rectangle? Parallelogram only, but the sides are at 90 degrees. So this is parallel to this is parallel to this, and angles are all 90 degrees. It is rectangle. Then we are coming to rhombus. What is a rhombus? Parallelogram only, but all four sides are equal. So this is parallel to this is parallel to this, and all are x centimeter. Means all are equal in size. This is rhombus. Then comes square. What is a square? It is a special type of rhombus only. So parallelogram first, opposite sides are parallel, then all sides are equal, and then all angle also are equal, which is 90 degree. So this is a square. So these are five special type of quadrilateral that we saw in previous slide, and we revised it again. Just remember them, their properties. Now, from parallelogram, as we saw, there are three more special type of quadrilaterals are derived. So this parallelogram has got certain property which will be inherent in rectangle, in rhombus, and in square. What are those certain properties? The certain properties, first one is opposite sides are equal. So in parallelogram, these are parallel, right? We saw that. But they will also be equal. So this is x centimeter, this is x centimeter, this is y centimeter, this is y centimeter. These sides also will be equal by default. So if there is a quadrilateral where opposite sides are parallel to each other, they will also be equal. Similarly, the second property, opposite angles are also equal. What does that mean? That basically means that this angle will be equal to this angle, and this angle will be equal to this angle. So opposite angles also are equal in a parallelogram. Now, what is the third property of a parallelogram? The third property of a parallelogram is each diagonal of that parallelogram bisects each other. So this is a parallelogram, and these are the diagonals of the parallelogram, right? So A, B, C, they are intersecting each other at, let's say, point O. So in a parallelogram, what will happen is this OD will be equal to OB by default, and AO will be equal to OC by default. So three property: opposite sides of the parallelogram will be equal, opposite angles will be equal, each diagonal will bisect each other. This property. Then there is a third property in parallelogram, rather fourth property in parallelogram. Each diagonal bisects the parallelogram. What does that mean? I have a parallelogram, right? Now this is one diagonal. This diagonal bisect the parallelogram means this area will be equal to this area, and all sides will be equal, and so on and so forth. So this is basically bisecting the parallelogram in half. Same would be true if I draw the second diagonal. So rather than this diagonal, if I draw this diagonal also, this is one area, this is one triangle which is coming out of parallelogram, this is second triangle which is coming out of parallelogram. Both will be equal in all aspect. Now, all these rules can be applied vice versa. For example, if pair of opposite sides are equal and parallel, it is a parallelogram. So if there are two sides in a quadrilateral, there are two sides, they are parallel to each other and they are equal to each other, we can by default say it is a parallelogram. So the fourth theorem is not that, or rather fifth theorem is not that relevant, because in this particular case, anything which is all the properties that we have seen, that property by default comes to this also. So please remember all these properties. Opposite side of a parallelogram are equal, opposite angles are equal, each diagonal will divide the parallelogram in two parts, and wherever the diagonal intersect with each other, it will be equal. It will bisect each other. Clear है यहाँ तक? So now let's right away jump to questions. Prove that the consecutive angles of a parallelogram are supplementary. What does this mean? Let's draw a parallelogram. So this is my parallelogram, right? A, B, C. Which are consecutive angle? This is one angle, and this is the consecutive angle. What I need to prove is angle C plus angle D equal to, are supplementary, means the sum of these two angles are 180 degrees. Now, how can I prove that? Very simple. Angle D and angle B, these two angles I know are going to be equal. So this angle is equal to this angle, right? And then the next one I know is this angle is equal to this angle. Angle A and C are equal. This is a property of parallelogram. So if I look at that property, very simple, angle A plus angle B plus angle C plus angle D is equal to 360 degrees. Quadrilateral hai. So all the angles, sum of all four angles will be 4 into 90 degrees, 360 degrees. Now, if angle A and angle C are equal, so I can write 2 into angle C, these two, and 2 into plus 2 into angle D equal to 360 degree. So angle C plus angle D, I will take 2 common, bring it here, 360 by 2 equal to 180. So it's a very easy sum. The consecutive angles of a parallelogram are supplementary. All four angles 360 degree, opposite angles are equal. So by default, sum of two consecutive angles will be 180. In a parallelogram, ABCD, XY are the point on the diagonal BD such that DX equal to BY. Prove that AXCY is a parallelogram. So again, let's draw the parallelogram. This is my parallelogram. A, B, C, D. What is happening in this? XY are the diagonal on BD diagonal. This is my diagonal. I have got 2 points. One is X, one is Y. What are we saying? DX equal to BY. This is what we are saying. Now prove that AXCY. So let's draw AXCY with a different color. What I need to prove is AXCY. So this is AXCY, right? AXCY is a parallelogram. Now to prove that, what do I need to prove? I need to prove two things. First, both the opposite sides are equal. That's one requirement. The another requirement is they are parallel to each other, right? So now let's look at two triangles. I'm looking at this triangle, which is CDX, and I'm looking at ABY triangle. Now, in these two triangles, what is happening? What all I know? I know this side is parallel to this side and equal to this side. This and this are equal, right? Second, what I know? This side and this side, which is by and dx, also is equal. So these two are equal. Now look at this angle. Angle ABY is equal to angle CDX, this angle, right? So in that case, triangle CDX and triangle ABY are congruent triangle, right? So if they are congruent triangle, what will happen? They are opposite side. So this side AY will be equal to CX, right? So the opposite side will be equal. That's the first thing that we have proven, right? What would be the another aspect in this particular case? The another aspect is this angle will be equal to this angle, right? This angle Y in this triangle is equal to angle X in this triangle, right? So based on this, if I look at, as we said, ABY is congruent to triangle CDX. And similarly, if you look at your this triangle, which is BCY, will be congruent to triangle ADX. So triangle ADX will be congruent to triangle CBY. Congruent, you understand, right? In two triangles are congruent, which basically means their corresponding angles are equal, their corresponding sides are equal, right? So in this particular case, so with that, what we can prove? With that, we can prove that this side is equal to this side, and in this case, this side is equal to this side. So opposite sides in that parallelogram are equal, and hence we can prove that AXCY is a parallelogram. Let's move to the next one. PQ are the points of trisection of diagonal BD of the parallelogram. Prove that CQ is parallel to AP. This is slightly tricky. So what we are saying is A, B, C, D is a parallelogram, right? Now it has a diagonal BD. P and Q are such that they are trisecting this diagonal, which basically means this, and this sides are equal. Now we have to prove CQ, which is this one, is parallel to AP. Now, how we can prove this? First, understand that. So if we have to prove this, let's extend this line, and let's extend this line, right? So in this line, if we look at this angle and this angle, these are what? Alternate angles, right? So if we can prove that these two angles are same, or rather are equal, in that case, we can prove that these two sides are parallel to each other. AP and CQ are parallel to each other, right? If alternate angles are equal, then the sides are parallel. Fair enough? So let's go back to this. So what we have to do is, I will take one triangle which is APB. This is my one triangle, right? And I will take my second triangle, which is this triangle, which is C, Q, and D. Now let's look at these two triangles. First thing, I know AB is equal to DC. That we can say for sure. AB and DC are equal because they are opposite sides of a parallelogram. So that much we can say for sure. What is the second thing that we know for sure? Which is this angle is equal to this angle, right? These are alternate angles. AB and CD are parallel side, BD is dissecting that, so alternate angle will be equal. So two things we have got. Now the third thing, if we are able to prove BP is equal to DQ, then triangle APB, which is my red triangle, will be a congruent triangle to triangle CQD, right? Because two sides and the angle between them are equal. Now, is BP equal to DQ? Yes, BP equal to DQ, because let's say DP is X, PQ is X, and QB is X. It is trisecting, right? So what would be BP? BP will be X plus X 2X and equal to BP. And what would be DQ? DQ again would be X plus X 2X. So in red triangle and in green triangle, AB is parallel to CD. This is parallel. This angle is equal, and this side in green triangle is equal to this side in red triangle. So in red triangle, this side is BP, that is equal to, in green triangle, this side, right? So once that is proven, which basically means now that corresponding angles also will be same. Corresponding angles will be same means this angle will be equal to this angle, and the second corresponding angle, which is this angle, will be equal to this angle, right? So corresponding angles are same. So from here, if I look at, I've got a parallelogram AB, A, B, C, D. This was the diagonal. This was X. Whether this is P, this is Q, AP, CQ. Okay. Now we have just proven that this angle is equal to this angle, right? We have proven that. So which basically means this is one line. If I extend, that would be more clear. So this angle, which is alternate angle to this angle, if they are same, which basically means AP is parallel to CQ. This line is parallel to this line. Hence, now let's come to this. In parallelogram ABCD, the bisector of adjacent angle A and D intersect each other at point P. Prove that angle APD equal to 90 degrees. This is very easy. Let's take this parallelogram. So A, B, C, D. Now the bisector of angle A is this, bisector of angle D is this, and they are meeting at P. What we have to prove? We have to prove this is 90 degrees. Very simple. Angle A plus angle D equal to 180 degree. We have proven earlier. So this entire angle plus this entire angle is 180 degree. This is one thing which we know. Second, what we know? Angle, this half of the angle. So this is angle A by 2. And this again is bisecting it. So angle D by 2. And angle P. These three put together forms a triangle. Hence, the sum would be 180 degree. So angle A by 2 plus angle D by 2 plus angle P is equal to 180 degree. This is second thing that we know. So if we simply solve this, it will come as angle P equal to 180 degree minus angle A plus angle D by 2. This is nothing but 90 degree. So angle P is equal to 90. Clearer? So easy sum. Let's come to the next one. Again, this is also quite easy. We have a parallelogram in our hand. So this is our parallelogram. A, B, C, D. Diagonals are intersecting each other at O. Now, OB is OB we know 6 centimeter, and AC is 6 centimeter more than, so AC, second thing that is given is AC is equal to 6 centimeter plus BD. Okay, so this is 6 centimeter. Since they are bisecting each other at O, because diagonal of a parallelogram basically bisect each other wherever they meet. So this is 6 centimeter, this is 6 centimeter. So overall BD is equal to 12 centimeter, right? Now second thing is given is AC is 6 centimeter more than BD. So AC would be 18 centimeter. So this whole line is this this entire thing is 18 centimeter, right? Now at O they are bisecting each other. So OC would be half of this. OC would be 18 by 2 equal to 9 centimeter. So again a easy one. Let's come to this. This is also not that difficult. This is a parallelogram, right? So A, B, C, D. Now, adjacent sides of the parallelogram are in the ratio 5:3. So if one side is 5x, this side is 3x. How much would be this side? 5x, because opposite side are equal. And how much will be this? 3x. So what would be the perimeter of this parallelogram? 5x plus 3x, 8x. This 5x plus 3x, 8x plus 5x, 13x plus 3x, 16x. So 16x is the perimeter of this parallelogram, and that is given as 96 centimeter. Then x is equal to 96 by 6, which is nothing but 16. So this side would be 80, this side would be 3 into 16, 48, and this is again 80, this is 40. So again a relatively easy one. One of the diagonals of a rhombus is equal to its sides. Find the angles of the rhombus. Now, this might look like one line problem, and it actually is if we think about it properly. So what is a rhombus? Rhombus, all side equal, opposite side parallel. That is rhombus, right? So this is x, this is x, this is x, this is x. Diagonal of a rhombus is equal to side. So this is a diagonal. Since that is equal to side, this is also x, right? Now, just let's look at this triangle. What is happening with this triangle? This is x, this is x, this is x. So this is an equilateral triangle. What are the angles in case of equilateral triangles? What is the angle of the triangle? Angle of the triangle is 60 degree. So this is 60 degree, this is 60 degree, this is 60 degree, right? So angle C is equal to 60 degree. How much would be angle A? Angle A would be equal to angle C, equal to 60 degree. This is angle A. Now angle A plus C plus B plus D is equal to 360. So angle B plus angle D would be equal to 360 minus 60 minus 60, 240. Now since angle B and angle D are equal, this angle, this full angle of rhombus, and this angle, are equal. So angle B equal to angle D equal to 120. As I said, it's a one line problem if you look at it